dot out there. Here's the only information they have. The measurement between themselves, 16 inches, and the angle out of parallel. I say, guys, I want you to calculate how far away that dot is based on that little angle change you get. I think that would be difficult to measure. 1 light year. You'd certainly be, there'd be some guesswork involved, okay? Now, if you want to measure 100 light years, you got a much worse problem. Now you got to move your dot 830 miles away. If we had two guys on the roof of this building here in Pensacola, Florida, 16 inches apart, and they're both focusing on a dot in Chicago, which is 830 miles away, but they don't know how far away it is, they're going to tell me how far away it is, based only on their angle of their telescope out of parallel. I would say that's impossible. Impossible. To measure 15 billion, no question that's impossible. I don't think you can measure 100 light years. Not with real numbers, not with real measurements, but this textbook says they can measure, parallax trigonometry can measure up to 100 light years. Okay, I doubt it, but I'll give them 100. I'll give them 1,000 if they quit crying, okay? The fact is you can't measure a billion. Simple fact. So here's some things to consider about starlight. It said in 2004 that the new SIM technology, Space Interferometry Mission, they hope to get where they can improve the distance of measuring to stars. And they say this accuracy will enable SIM to determine stellar distances to 10% accuracy out to a distance of 482,000 million miles. That's 82,000 light years. And then it says, this is an improvement of several hundred times over what is possible today. Well, now, wait a minute. If they're going to improve it several hundred times, and it ends up being 82,000, what's 82,000 divided by several hundred comes out to be several hundred. Apparently, they're admitting they can only measure several hundred light years, which I would agree. I mean, I would say that's even a stretch, but I'll give them several hundred. They can't measure billions, is the point. So when you students in school get taught, oh, that star's, 14.629, billion light years away, say, I don't believe you. I don't believe you at all. It might be, but you can't prove that. They're making up a story. With SIM technology, they hope to finally be able to get out to where they can measure most of the way across our galaxy, and we're in it. We can't even measure across our own galaxy, let alone these distances to other galaxies. So I think we should look at the stars and say, wow, what a mighty God we serve. Instead of going out there and say, well, we know how far that way it is, we know it evolved. I mean, it's just that egotistical attitude some of these atheists get, makes you want to slap them in the face, like, man, why don't you serve God? Look what he made, Here's the things to consider concerning starlight. Then we'll take a break. Number one, we cannot measure these great distances. They just cannot be done. Number two, nobody knows what light is. They call it a wave or a photon or a particle. We know what it does. We use it all the time. But actually, give me a jar of it and paint it red. Nobody knows the substance of it. What is light? And we sure don't know that it always travels the same speed all through time or space. The entire theory behind a black hole is that light can be attracted by gravity. Well, if light can be attracted by gravity, then you cannot say the speed of light is a constant. Okay? At Harvard University back in '99, they slowed light down to 38 miles an hour. The next year, they slowed it down to 1 mile an hour. And the next year brought it to a dead stop. Light goes, pretty quick, 186,000 miles a second. They slowed it down. It was done at Harvard. It was done at Smithsonian. It was done at Cambridge University. A repeatable, demonstrable experiment. Now that is science. If you do an experiment, get a result, somebody else follows your data, does the same experiment, gets the same result, that's science. They slowed light down. This article came out on Fox News Channel. They said, we've succeeded in holding a light pulse still. They brought the speed of light to zero, brought it to a dead stop. Meanwhile, back in 2000 at Princeton University, they speeded light up to 300 times the speed of light. So when somebody says that star's 10 billion light years away, which I doubt they can measure, therefore that we can prove the universe is 10 billion years old, they got several problems in their logic right away that they probably don't see, which is why we do these seminars, so we can help people understand. It's 300 times the speed of light. Astronomer Barry Setterfield, Australian government astronomer, said, during the last 300 years, 164 measurements of the speed of light have been published using 16 different measurement techniques. The speed of light has apparently decreased so rapidly, experimental error cannot explain it. This is a chart showing the decline in the speed of light from the published numbers in the last 150 years. You notice the decline in the chart. The speed of light's getting slower until about 1960. For the last 40 years, anybody that's measured the speed of light gets the same number, 186,282.4, I think, miles per second. Who cares? Well, it could be that it leveled off in 1960 for two possible reasons, three possible reasons. Our way of measuring is getting better. Instruments are getting better. We're smarter. You know, everybody in the past was dumb. We're smart. We got it right. Could be. That's what they'll tell you. Second option, though, is we're at the tail end of a logarithmic curve, and you're much less likely to see any decline. As you get further out on the logarithmic curve, it pretty much levels out. But a third reason is 1956 is when they invented the atomic clock. And they started using that as their clock to measure the speed of light. Well, now, wait. The atomic clock is based on the wavelength of a cesium-133 atom. So the clock is based on the speed of light. Now, if you have a clock based on the speed of light and you're measuring the speed of light with it, if the speed of light changes, you're never going to catch it with that clock. It's like watching two twins grow next to each other. Well, neither one's growing. Well, duh. You got a rubber ruler problem here. Clear back in '87, they said the speed of light was 10 billion times faster at time zero. There must have been a faster speed of light. There have been articles from the 80s, 90s, 2000s saying, look, the speed of light is not a constant. They said no physical law prevents anything from exceeding the speed of light. In two published experiments, the speed of light was apparently exceeded by as much as a factor of 100. The Big Bang Theory requires a much faster speed of light. Dr. Magluocchio, however you pronounce his name here, I got his book on the table. He says, a shocking possibility is the speed of light might change in time during the life of the universe. Could it be the speed of light was faster? Here's an article in the newspaper said, speed of light may have changed over history, study says. Winnipeg Free Press, nothing's reliable, not even the speed of light. We have shown that a time-varying speed of light could provide a resolution to well-known cosmological puzzles. One of the mysteries of a decaying speed of light seems to be able to explain why opposite extremes of the cosmos that are too far apart to have been in contact with each other appear to obey the same rules of physics, and even about the same temperatures. It would only be possible for light to cross from one side to the other if it traveled much faster than today, moments after the universe was created. Is the speed of light really a constant? There are articles here in Reuters News Service, the speed of light may not be a constant. I have dozens of articles like this in the last 15 years, and this will be much more detail in our college class about the speed of light. So don't let somebody tell you the speed of light is a constant. We don't know that. Big article came out in Discover magazine, says, was Einstein wrong about the speed of light back in 2000? He said, yeah, Einstein was wrong. The speed of light is not a constant. There's the book by the Italian scientist, I'm assuming he's Italian. It says, look, the speed of light is not a constant. And there have been many articles published about this. You can read them for yourself. I'll flash through them quickly here and you can get the details. So the third thing to consider, the creation was finished when God made it. Not only can we not measure those distances, not only is the speed of light not necessarily a constant, the creation was done. See, Jesus made wine out of grapes that never existed. He missed all that time. Instead of going from the water in the ground, through the plant, into the grape, squeeze it, make the wine, now drink it, no, Jesus turned the water straight to wine. What happened to all the intermediate steps? God can bypass all that. He doesn't need any of that. Okay? I ask people the question, how old was Adam on day 6? Anybody know? How old was Adam on day 6? 0. Did he look 0? No. He looked 52. 53 next month. But he looked perfect top, physical condition. God didn't make 2 babies and put them in the Garden of Eden and hand them a package of seeds and say, here, plant these quick. You're going to need supper. It has to be a full-grown man, full-grown woman, full-grown garden. They got to have supper like tonight, Better be something hanging on the tree ready to eat. Even if you plant a tree, you're going to take 4 or 5 years to get fruit off it. So the creation had to be mature. A fourth thing to consider about the speed of light question, a light year is a distance, it's not a time. It's a distance. And since the speed of light is not proven to be consistent, why would star distance have anything to do with the age of the universe? Now, I am not saying, and have never said, all of the stars are inside of a 6,000-mile radius of the Earth. That is not what I say. I don't know any creationist that teaches that. So when they say that, they're setting up a straw man, knocking it down. They're lying, basically. The stars probably are billions of light years away. They probably are. We just can't measure them, that's all. I like this article in the Discoverer. It said, how do scientists measure the age of stars? They said, well, we can find the absolute ages by comparing a star's color and brightness with those in stellar evolution models. What? We can tell how old it is by how old we think it is. That's exactly what they're saying right there. That's dumb, okay? Now, I think everybody's asking the totally wrong question. Everybody's saying, how did the light get from the star to the earth? They're asking the wrong question. 17 times in the Bible, it says God stretched out the heavens. Well, if He stretched out the heavens, they're asking the wrong question. It's not how did the light get from the star to here, but how did the star get from here to there? That's the question we need to be asking. The Bible says pretty clearly God made the earth first, and then He made the stars also. And He stretched, suppose He made the earth, and then He stretched out the stars from here. Adam would see the stars on day 6, and day 7, and day 8. As the star is being stretched out into place, it's going to leave behind a trail of light. So the stars could be billions of light years away today, and still have been created in the 6 days, 6,000 years ago. Russell Humphreys has a book which I read, and I just have to say, I didn't understand it, all of it. He's really, really smart, but it's a good one on starlight and time if you want to get more on that. I don't know that I agree with his premise. I think he starts with the assumption the speed of light is a constant. Now, how do we explain that? And they get into this warped space and bent space stuff. I think it's much simpler. The speed of light's not a constant, and God made things and stretched them out into place. So, if that stretching took place, maybe that explains why we have a red shift. And we'll cover the red shift question in just a minute after the break. Okay, let's go on to the question we often get, well, what about the red shift? Doesn't that prove the universe is expanding? Or doesn't that prove the universe is billions of years old? Let me explain what they're talking about. If light shines through a prism, it breaks it up into the rainbow colors, red, orange, yellow, green, blue, indigo, violet, okay? Well, if you take starlight and shine it through a prism by putting a prism on the back of your telescope, you look at the star, the light comes through, and it gets broken up into the same red, orange, yellow, green, blue, indigo, violet. And you can kind of tell what's burning because different things burn different colors, like copper burns green. And each element produces a distinctive color. And so they can kind of tell what's in the star and how it's burning by what color of light it produces. So you can learn a lot about the star from the light. However, as they look at the spectroscope, the colors it produces, there's little black lines in starlight indicating something's burning, a particular element's burning, but they're shifted toward the red. If you notice the center picture up there, its black lines are shifted over toward the red side, and that's called the red shift. So the question is, what would be causing this? Why would some of these stars have the black lines shifted over toward the red? Well, there are several theories about what's causing it. The most commonly accepted theory, and probably the only one that students are ever taught in school, is that the red shift is caused by what's called the Doppler effect. If you've ever been waiting at the train tracks when a train is coming, as the train's coming toward you, it is squeezing the sound waves, and so the pitch goes up. And when the train leaves you, it is stretching the sound waves, and so the pitch drops, and it goes as it goes by. That's called the Doppler effect. Who cares? Well, this happens, okay, whether the sound is moving past you or you moving past the sound, it doesn't matter. You still get this Doppler effect, the change in pitch. Well, the theory